Hi everyone, welcome to Cola Teaches Math. I'm going to do a quick video on properties of integrals. So let's see what we got going on. So usually a property of integral question, they're going to give you some information about some integrals. So if you look at what I'm boxing here in purple, they tell us the integral from 1 to 4 of f, the integral from 1 to 7 of f, and then I color coded and I did another integral from 1 to 4 of g. Okay, so the first property, and remember what the integral is, it's the area under the curve. So the first question, I'm saying, hey, what's the area from 1 to 1 of f? Well, that's going to be 0. And what property that is if we're integrating from a to a, we're not actually moving. So that is going to be 0. The area is going to be 0. Okay, number 2, how do I proceed? Well, split up the integral. Anytime somebody is asking you to add two integrals together, I would start by giving the integrand and the dx to both of them, like this. And now you're going to go ahead and say, okay, well, the area from 1 to 4 of f is 5. The area from 1 to 4 of g is 2. So you're going to replace them. We're going to have 5 plus 2. So we're going to get 7. Okay? All right, question 3. If they ask us for the area from 1 to 7 and they're doubling it, all we're going to do, you don't have to show this work, but this is what it is. So we're going to pull the constant in front. We're going to take the area from 1 to 7, which is going to be 12, right here. And then we're going to double it. So we're going to get 2 times 12, which is 24. Okay? All right, question 4 and question 5, I test a lot in my class. Please notice the difference where the dx is being placed. So if you notice in number 4, dx is following the f of x, but in question 5, dx sandwiches the whole thing and it's at the end. So for question 4, we are going to find this integral, the area under the curve. So from 1 to 4, that is going to be in orange right here. Right here. So that's going to be 5. And then we're just going to add 3 to my answer to get 8. But if the dx is at the end, it means we have to integrate everything in between what I'm highlighting in blue. So we actually need to split up my integral. And we need to go from 1 to 4 f of x dx plus 3 integral 1 to 4 dx. Well, this guy right here, we know that area from 1 to 4 is 5. And now this guy right here, we actually need to integrate the 3. That's ugly. Okay. Because whatever is in between these symbols, we have to integrate it. The integral of 3 is 3x from 1 to 4. We always plug the upper bound in first. So we're going to have 3 times 4, then the lower bound, 3 times 1. 12 minus 3 is 9. So now this pink bracket is going to be 9. 5 plus 9 is 14. Okay? I'm going to actually change this one over here and make it, so my new question 6 from from 7 of f of x dx. Now obviously you can use a property of integral that says you could split the integral up, but I like to teach it in my class using a number line. So I say, hey kids, look at the numbers that are on the integral, 1, 4, and 7. Put them in numerical order on a number line. And it's just a visual way to represent the area. So the area from 1 to 4 is 5, because that's what I gave you. So this area right here is 5. Then the area from 1 to 7 is 12. So this entire thing right here is 12. And if I want to know the missing area, 4 to 7, it's just like algebra. Hey, 5 plus what equals 12? 7. Done.